continuing where we left off, we talked about what we observed. The blue copper 2 sulfate hydrate slowly started losing that blue color as it became kind of white, the anhydrous copper 2 sulfate. Magnesium chloride and the anhydrate salt of magnesium chloride are kind of white in color, except one has a nice crystalline kind of looking structure to it compared to the anhydrate, which has like a dull powdery white color. So the result was that the mole ratio of water to the anhydrate is 5:1, and therefore the empirical formula of the hydrate of copper 2 sulfate is CuSO4.5H2O. In experiment 2, the mole ratio of water to the anhydrate salt is 1:1, and therefore the empirical formula of the hydrate is MgCl2.H2O. So conclusions. What did I learn from these experiments, and what would be a real world examples of how I could use this information? There are compounds that exist, especially those inorganic compounds which have loosely bound water molecules, or water of crystallization, as to be more precise, in their crystal structures. So these salts are hydrates. So when you heat the hydrate, the compound decomposes and releases the water molecules as vapor. So once those water molecules leave the crystal structure of the hydrate, it alters their structure, and so many times those anhydrates are going to be different in color compared to their corresponding hydrate. So CuSO4 5H2O was blue, but its anhydrate was that fine white powder. All right, copper has a tendency, copper ions, when they dissolve in water, to have that nice deep blue color. So once the water is taken out, it kind of becomes that whitish color. Now this is also seen with another compound, cobalt 2 chloride, which has 6 water molecules in its crystal structure, and it has a nice deep burgundy kind of color, a deep reddish color, but its anhydrate is blue in color, right? So cobalt 2 chloride is blue in color, minus the water, it's blue in color. A real world example for the use of these hydrates is mainly as drying agents. They're called as desiccants. So if you take the anhydrous calcium chloride, you can keep it in a desiccator where you need to keep samples dry. All right, so this is frequently done all the time in labs, where you want your sample to be very dry and not absorb moisture from the air. So you'll put it in this special container called a desiccator, and the desiccator has calcium chloride to absorb any kind of moisture and keep the sample dry. Desiccants are used also in other items like shoes, toys, clothing, packages where you need to not have that product be ruined by moisture. So silicon dioxide is basically one of those desiccants that is used. You frequently see this in handbags or shoes especially, and it'll just absorb the moisture so that the shoes are not damp and they're kept dry. Dehydrating and rehydrating food, like vegetables or fruits, or the MRE rations used by the military. All right, this improves the shelf life of food. All right, There are hydrates that are used in medicine, like chloral hydrate. It's used as a sedative, especially for patients before they undergo surgery, right? Certain medications, which are hydrates, have to be maintained at a certain temperature, or they might lose their water of hydration. And then if they lose that water of hydration, they become ineffective, right? So the anhydrate doesn't work as effectively as the hydrate. And that ends this video in this lab.